Welcome student, welcome back to our class Automata Language and Computation ALC for the CSE. Okay, and in the last class we discussed about the syllabus and what is a credit. Okay, it this subject has 3 credit, and we saw the syllabus as well as we saw the course outcome, like after finishing this what you can able to do. Okay, so for in today's class we are going to see the introduction of ALC, Automata Language and Computational, basic things. Okay, so first thing we will see the introduction of automata theory. You can say automata theory, as I told you in the previous class. You can say automata theory, or you can say the automata language and computation, and you can say theory of computation. Okay, so you can say this 3 name to the automata language and computation. Okay, so automata theory is a branch of computer science that deals with designing abstract self-propelled computing devices that follow a predetermined sequence of operation automatically. Okay, as I told you in the uh, last class, so this is an automata machine. Like if I gave the example of ATM. So what is this ATM? ATM will take the input. Okay, it will take the input and it will perform some operation, and it will give yes or no. So here operation or thinking, whatever the thing are there, this is a thing. So first it is taking the input and doing some operation or thinking or doing some work. Then after that it will give the output either yes or no. Okay, so in the same, it is a self propelled computing devices. It does not need anyone. It is self computing devices. Okay, so this is very important for the computer science student. Okay, and next point, and automation with a finite number of state is called finite automata, FA. This is very important. Okay, FA, finite automata. So here in the automata theory is there will be a finite and another one is infinite. So finite is the automata with a finite number of state is called a finite automata. So what is finite number of state? I will tell you, like finite state of finite number of state is nothing but like it will give like sigma 0 comma 1. So this is a finite number of state, and you will going to see what is the sigma, what is this. I will tell you in the coming slides, but just to tell you, the finite number of state is like this, means there will be a limit of the state. How many states are there? That should be limit. Okay, that is called finite number of states. Okay, now, so what is automata? The automata is derived from the Greek word. Okay, it is derived from the Greek word automata, which means self-acting. As I told you, I gave you the example of ATM. Okay, self, it will do some operation and give the output. Or you can take the example of computer also. Okay, so ATM is automatic teller machine. This machine can perform self-acting. Okay, okay, now, and automata is plural and automation is singular. Okay, automata in plural is an abstract self propelled computing device which follow a predetermined sequence of operation automatically, as we saw in the previous slide. So this is self acting automation is singular, and automata is nothing but plural. Okay, and automation with the finite number of states is called a finite automata, FA. Just now we saw what is a finite number of states, or finite state machine. As I shown you the diagram, I hope you remember in the previous class. First was F S M. This was in the first circle. Then in the second circle, there will be a context free language. Okay, in the third, push down automata or turning machine. And in the next circle, last one, unpredictable or undecidable. Okay, so this is a circle. So first we will see this FSM, finite state machine. Okay, and this is a Greek word. Now, so before going to see uh, in detail, first you need to know the basic thing what we are going to do in automata, finite automation. Okay, formal definition of the finite automata is an automata sorry an automation can be represented by a five tuples. First, q, let me change the color, in color blue. Okay, so tuple q, first one is a capital Q, second one is a sigma, and delta, q0 and f. With this phi we can define the finite automation. Okay, first one is a capital Q, sigma, delta, q0 and f, capital F. So what is this Q? Q is a finite set of state. As I told you, finite set of state is nothing but like sigma is equals to, there will be like 0 comma 1, or it may be sigma is equals to a comma b comma c. Okay, anything that should be a limited, or a to z, clear, or 0 to 9. Like this you can take the numbers. So sigma is equals to a comma b comma c. This is a finite number of states, finite set of states. Okay, now what is second one? Sigma is a finite set of symbol called the alphabet of automation. So here in the sigma, whatever the sigma is there, that is all we will say alphabet. In the alphabet, all the numbers will come 0 to 0, 1, okay, 0 to 9, small a, b to small z, okay, or capital A to capital Z, and special character as well. Okay, we can add the special character. So this all will come under in sigma. Okay, alphabet. Fine. Delta is a transition function, and whatever the transition function from uh, initial state to final state. Okay, this is the initial state and this is the final state. Example. And how will you define between initial state and final state? I will tell you. So this is transition, like here, going and getting back, and here like this, and like this. Okay, so lambda is nothing but a transition function. Like if you go to ATM, again and again I am taking the ATM example because this is an automata machine. So here in the machine, transition, when you are giving input. So whatever it is happening here, there is a transition, and we will get the output. Okay, so here q0, what is this q0? Q0 is a initial state, and initial state will represent as like this circle. This is called state. If that state has this arrow, that means it is a initial state from where any input is proceed. So q0 belongs to q. So whatever the finite set of state in this, that will be here. Okay, so take this example, 0 1, sigma 0 1. Okay, if initial state q0 is 0, then is go to the initial state only. If it is 1, go to next state. So next state will be our, like, take q1. Okay, so here in the q1, if it is 0, this, if it is 1, like this. Okay, so here in this q0 is the initial state, and q0 belongs to q, this finite set of state. Means if you are taking sigma is equal to 0 comma 1, so you cannot take here 2, you cannot take this. Why? Because this is not belongs to q. Are you getting my point? Whatever the things are there, whatever the finite set of state in the given problem, that should be in the that should be belongs to q0. Other than capital Q, it will not allow and it will not accept. Okay, fine. Okay, capital F is a set of final state or states of qf subset of q. So here it is not compulsory that you will have only one final state. You may have the more final states, and there will be a possibility like initial state can be a final state. Okay, and there will be a more than two or more than one final state will be there. Okay, and what is this q? Q is f subset of q. So whatever the in q, there is a subset of f is a subset of q. Okay, so this is basic thing. Once again I will just tell you. Okay, in this 5 tuples are there. Automata represented by a 5 tuple. First one is q, capital Q, sigma, delta, q0, and final state. Okay, and q is a finite set of state, like as I told you, sigma is equal to 0 comma 1, or sigma is equal to a comma b comma c, anything. This is called finite set of state. Okay, sigma is a finite set of symbols called alphabet. So whatever you are taking here, a b c 1 2 0 1, small abc, capital ABC, that is called alphabet. And the delta is a transition function. Whatever the transition is going on here, like here, all, this is called delta. q0 is the initial state from where any input is processed, and q0 belongs to capital Q. So q0 is the initial state, and initial state will represent as q0, like this. This is called initial state. Okay, fine. And capital F is a set of final state or states of Q, F subset of Q. So here Q1, if you have the double circle, that means this is a final state. Final state. And you may have more than one final state. Okay, so this is a simple formal definition of finite automata. Okay, next, some of the related terminology, if you are going to this in finite automata, like alphabets and all, we will see that. Okay, so here the related terminology. Alphabet, what is the definition of alphabet? Definition: an alphabet is any finite set of symbols, that is called alphabet. Any any set has a finite set of symbols, that is called alphabet. So here the example is this. Example: sigma is equals to a comma b comma c comma d. This okay, 4 and is an 4 symbols are there, so is an alphabet set where a comma b comma c comma and d are symbols. Okay, so whatever the symbol, the finite set of symbols, if you are using, that is called alphabet. Okay, fine. Okay, so the next is string. What is a string? String is definition. A string is a finite sequence of symbol taken from sigma. It means, like here it is taken ABC. Okay, we will go with this example. So sigma a comma b comma c, how many possibilities can be? Okay, string, what is S? String is equals to first A, B, C, D, or A, B, C, D, or A, sorry, yeah, A. So you can group of symbols making A, B, B, A. So this is the possibility of this, and so on. Okay, for this given symbol A, B, C, D, so we can make a string like A, B, C, D. Then A, B, C, D is one string, A is one string, A, B, B, A is one string. So you can make multiple strings. Okay, and this is a valid string. Example: S is equals to, if I am making A, B, C, D, E, and here X, Y, Z. This is not a valid string. Not valid string. Why it is not valid? Why? Because in the sigma, whatever the symbols are available in the sigma, that symbol only should be used here. Here we are using A, B, C, D, but we are adding E. This is not in the given symbol. Because of that, not valid. XYZ is not here, not valid. Okay, so whatever the things you are taking from the alphabet, from the sigma, that is combination of the symbols which is available in sigma, that is called string. So this is a valid string. Why it is valid? Because A, B, C, D, yes, here available. A, B, C, D, A, yes, A is available here. A, B, B, A, yes, A and B both are available here. So like this, you can check the valid string. Okay, and here it is not valid because it is not valid. A B C D E, A B C D is there, but E is not available in the given sigma. Because of that, it is not valid string. Clear? So this is I hope you understand. So alphabet is sigma and the string is from the finite sequence of symbol taken from the sigma. Okay, next. Okay, now we will see the length of string. What is the length of string? Okay, because just now we did here like a b like this. So here we will see the string. So here definition, it is the number of symbol present in a string donated by s. So here take like this, it will tell you what is the length. So before that, what is the string example? Here the same, I will take sigma is equals to a comma b. Okay, so what we can make a comma b? So here first we can make aa, then we can make ab, we can make bb, we can make ba. Okay, so this is a string. Clear? This is a string. So here you can take any one of the string. Like what is the size of string? 2. What is the size of string? 2. What is the size of string? Is 2. What is the size of string? Is 2. Okay, so you can increase. This is like 2 set. Okay, taking the 2 symbols and making the combinations. So S string is AA, AB, BB, BA. This is a valid string. Why? Because we are using whatever the things are available in the given sigma, that we are taking symbols and we are making the string. Okay, definition. So this is denoted by S. So string means anyone can take 2 example. So here take the example of here, S is equals to C A B C A D. So you can make like this. So what is the size of this string? Is 6. 1, 2, 3, 4, 5, 6. So what is the size of the string? Is 6. If it is denoted by this mod s, that means you need to define the string size. If normal s is there, so you need to define the string. Okay, if s is equals to 0, it is called an empty string denoted by lambda. Okay, denoted by lambda or epsilon. Okay, so this is a about string. Next, Kleene Star. Here this is a definition. The Kleene Star sigma star, it will denoted by sigma star, is a unary operator on a set of symbol or string sigma that give the infinite set of all possible string of all possible length over sigma including lambda. Here, like here, what is the length of the size? Length of the string is here is s, but here what it is telling? Kleene Star sigma star is a unary operator on a set of symbols or string sigma that give the infinite set of all possible string of all possible lengths. So here, if you want length is 2, so you can make like this. If his length is 4 for the given symbol, okay, given symbol, so you can make AABB is one possibility, or AB you can make 4. The length of the string is 4, so you can make with the given symbols, you can make like this. Okay, so it is the Kleene Star will help us to get the infinite set of all possible string of all possible length over sigma, including lambda. Lambda is nothing but, why we are using lambda, because we told here if the empty string is there we will use the lambda. Okay, so here how it will represent is sigma star is equals to sigma 0 union sigma 1 union sigma 2. What is this sigma 0 sigma? This I will tell you. Fine. Here sigma 0 a comma b. Okay, first it will be a sigma given a string a comma b. With this possible we can make one string. This is one string. Okay, next sigma 1, can we make aa ab ba and bb? And for kinder information, a b and b is different. Okay, so we can make the possible. What is the length of this? This is the length is 2. What is the length of this? 1. Now same sigma 2 is equals to a comma aab comma aba comma abb comma bbb, like so on. So what is the length here? What is the length? This is 3. Like this 4 5 6, okay, so on, infinite. So this infinite set of all possible string of all possible length. So whatever the possible length, like 1 2 3 4, any possible length we can get. And here with where e is p is a set of all possible string of length p. Sigma p is a set of all possible string of length p. So example is, if sigma is equals to ab, sigma star, this should be include. This should be include, because if the empty string is there, this will represent. If we have something in our sigma, okay, so we can take like c. Just now I shown you here. So it's the same thing. AB we added here. Okay, this we added here. Next AA, AB, BA, BB. So here the length of the 2. Then again here we can add AAA comma AAB, like this, so on. So we can add in the length. So what is Kleene Star? Kleene Star is a unary operator on a set of symbols or string sigma that gives the infinite set of all possible strings of all possible length over sigma, including lambda. Okay, so this is Kleene Star, and this is important. Okay, this is important. Fine. Next is Kleene closure or plus. Okay, what is Kleene Star and Kleene closure? You can differentiate after finishing this. Kleene closure or Kleene plus. What is the definition? The set Kleene plus is the infinite set of all possible string of all possible length over sigma, excluding lambda. And what is here? Here including lambda. The same thing is there, but the difference is if you have the sigma star, then you should include the lambda. If you are going with keen closure or keen plus, then sigma plus, then we need to exclude the lambda. Here all the same thing, representation sigma plus is equals to sigma 1 union sigma 2 union sigma 3 union so on. So here we need to remove, what we need to remove, this statement is extra. Sigma plus is equals to sigma star minus lambda. After removing the lambda, you will get sigma plus a comma b comma a b b b a, like this a. So what is the difference between keen closure and keen star? If we have the keen star is, it is a set of symbol, okay, or string, and that give the infinite set of all possible string of all possible length over sigma including lambda. So in the keen star, only the what is the major difference between keen star and keen closure is keen star will include the lambda and keen closure will exclude the lambda. This is the main important thing. Clear? Okay. So here also you can take sigma 1, sigma 2, sigma 3. Uh, you can say like this 1, 2. Same procedure you can follow here, keen closure or keen plus. We can take a b, okay, then keen closure a comma b comma a b. We need to find all the possible length over sigma, okay, infinite set of all possible string of all possible length, okay, clear. Okay, so here in the next one is prefix and suffix of the string, okay, prefix and suffix of the string. So here prefix string means number of leading symbol of the string. So string is ABC example. String is ABC is, so first you need to take A, then AB, then ABC. Okay. If we talk about the prefix string means number of leading symbol of the string. So string is ABC. So here prefix of the string is, first will be the epsilon A, AB, ABC. Okay, like this you will get the prefix string. Clear? Fine. Now, and example, epsilon a comma a b c d. Can we write like this? We cannot write. Whatever the string we have, that alphabet should be used here only. A, okay, AB, okay, ABC, okay, ABCD. No, this is not a valid, and you should not take like this, okay, till here only. Okay, so prefix, I think you understand this prefix, very simple. Prefix is prefix string means number of leading symbol of string. If we have the ABC string, so we can epsilon a comma ab and abc. Okay, what is suffix? Suffix of the string, number of its trailing symbol of the string. So here suffix. In the suffix, the same thing, ABC. ABC string is there. So here in the string, we can write epsilon, comma, you need to come from the last. You need to come from the last. So first we will write C, then BC, then ABC. So this is a suffix. Okay, this is a suffix. Prefix and suffix is also will helpful for coming classes. So remember this. Don't get confused between prefix and suffix. Prefix means prefix. Remember, prefix means first. Suffix means last. Remember like that. Then it will be easy for you to solve the problem. You can get the solution. Prefix means first. In the given string, you need to take the first, then first second, then first third, 1 2 3, then 1 2 3 4 5, like this. In the prefix, if you go to the suffix, then you need to come from the last, then last minus length, then last minus 2, last minus 3, like that. Okay, you need to get this epsilon C comma BC comma ABC. So this is prefix and suffix. Okay, now what is language? This is also very important. This is also very important because you must know language is not, as I told you in the previous class in the introduction itself, language is nothing but it is not a like programming language. It is not a programming language. Okay, it is not like a programming language. It is like a string. It is a string. It is a string, and that we will, with the help of a string, we will solve the automata problems or automata theory. Okay, what is the definition? A language is a subset of sigma star. What is this sigma star? This is Kleene Star. Okay, for some alphabets, sigma, it can be finite or infinite. Okay, it is, yes, definitely. Sometime we will get the finite number of states, sometime we will get the infinite number of alphabets. Example, if the language takes all possible string of length 2 over sigma. So here we are taking all possible, we are taking from the language, okay, from the language all possible string of length 2. So we have the AB, and from here all the possible length of 2. 2 means, yes, this possible AB, AA, OK, BA and BB. This is a valid, and we are getting the length 2. If we say length is 3, so what will be the language? A, then AAB, then A, B, A, then ABB, and so on. We will get all the possible solution. Like that, if it is go, then it will definitely, it will go to the infinite. So sometime we will have the finite number of alphabets or length or language, and sometime we will have the infinite. Okay, so this is about the language, and every time whenever we see the language, it is a set of string. Okay, and Kleene Star for some alphabet sigma. Okay, so what is subset of, so subset is sigma star for some alphabet sigma. Okay, so where is the cursor? Here L is a subset of sigma star. Okay, fine. So this was about today's class. Okay, And in the next class we are going to see like finite automata can be classified into two types. First one is deterministic finite automata, and next one is non-deterministic finite automata, NDFA or NFA. Okay, so just quickly review what we have done. First, we saw the introduction of finite automata. Then we saw from where the automata words came, and automatically it will perform. And the finite number of state is called finite automata FA or finite state machine. So here in the formula definition of finite automata is 5 tuple. This is very important. You must know and you must remember what is Q. Q is a finite set of state. What is sigma? Sigma is finite set of symbol called alphabet. And what is this delta? Delta is a transition function. What is q0? Q0 is initial state. And how q0 is initiate? Represent like this state with this arrow that will represent as initial state, and q0 subset of q, finite set of state. Sorry, q0 belongs to capital Q. F is a set of finite state or states. So F subset of Q. F is a subset of Q. So here we will have final state. Final state will represent as double circle, that is final state, and more than one final state can be there in our transition, in our finite automata. In finite automata we can get more than two final states. Okay, so this is a finite automata definition. Some related terminologies. What is alphabet? Alphabet is not only A, B, C, D. So that is, alphabet is a set, any finite set of symbol. This is finite set of symbol. This is called alphabet. Okay, where A, B, C and D are symbol. Clear? So here the string. String is nothing but with the help of this given string, given alphabet, we can make the string. So the string is a finite sequence of symbol taken from sigma. That means you can make the string, but that should be taken from the sigma. So whatever the alphabets are there here, that only you must take up. Which alphabets are not available in this sigma, you cannot make a string for that. Okay, so I shown you the valid string, not valid string. Okay, next, length of the string. So in every string we will have the length of the string. If it is tell you to make a 2, length of the string is 2, so you can make a b b b b a. If it is tell you to make a string of length is 4, so you can make a b a b a b a b b b. Like this, with the given sigma, given alphabets, we can make the alphabet strings. And normal s will represent as a string, and mod s will represent as length. And we will call the empty, if we got the 0, that means denoted by lambda or epsilon. Okay, empty set. Then Kleene Star we studied. What is Kleene Star? Kleene Star include the lambda, and it is a unary operator on a set of symbol or string sigma that give the infinite set of all possible strings of all possible length. Okay, now representation, I told you sigma star is equals to sigma 0 union sigma 1 union sigma 2 union so on. And one more important thing in the Kleene Star and Kleene closure or plus, in Kleene closure it will not include sigma 0. Can you see? It will not include the sigma 0, but in Kleene Star it will include the sigma 0. Okay, this is also one major difference between Kleene Star and Kleene closure. What is the first difference? Including lambda in Kleene Star, and closure is not including, means excluding. And what is it? Is starting from the sigma 0 Kleene Star, and closure will not start from the sigma 0. Okay, so if sigma is equals to a comma b, sigma star is equals to lambda. Lambda is an empty string, a comma b comma so on. Okay, now, so this is Kleene closure. It will represent as sigma plus prefix and postfix. Prefix is nothing but first. If we have a string, so first thing we need to take a, then b, ab, then abc, like that. Okay, and this is epsilon. Suffix is nothing but abc, so you must take the last, then last minus 1, then last minus 2, like that we will get the result. Okay, like epsilon c bc abc. Here I showed you. Okay, fine. Language. What is language? Language is a set of strings in automata theory. A language is a subset of sigma star. For some alphabet sigma, it can be finite or infinite. If the language take all possible string of length 2, or sigma is equals to a comma b, then this is all possible string. All possible string for the given length is 2. Okay, so this will be in the next class. Clear? Thank you. uh, Thank you very much.